Assalamualaikum and salam sejahtera. My name is Hikmal Hakimi bin Badrul Hisham. I'm from class B092010016. Section 1/1. My metric number is B092010016. Today, me and my group will explain about lab 3. The lab is pinned on this lab. I will explain my part, which is the theory and the objective of this lab. Okay, as we know, this lab we are going to use a tribometer as the instrument. Okay, tribometer is a machine that measures tribological qualities such as coefficient of friction, friction force, and wear volume between two surfaces in contact. The pin on this is a specific types of tribotester, which is the name given to a machine or device used to perform tests and simulations of wear, frictions, and lubrication, which are the subject of the study of tribology. Tribotester are extremely specific in their function, and the pin on these frictions and wear tester is no exception. The pin on this tribometer is a test instrument designed for precise and repeatable tribological characterization of bulk materials, coating, and lubrication. The popularity of the method is due to its relative simplicity and abundance of the tribological context that can be well described by a simple pin on this motion. Film lubrication is indispensable for long life of high-speed bearing, very useful in common machinery. For this lab, we are going to apply Coulomb's law. The formula for Coulomb's law is Fr equal to micro times Fn, where Fr is linear friction force, Fn is normal force, and micro is dynamic or static friction coefficient. The objective of this lab is to reduce the severity of both the normal and shear stresses in solid surface contact. We will use different types of material of the pin to run this lab. Okay, I will explain about lubricant and hydrodynamic lubricant. Lubricant is a substance used to facilitate relative motion of solid bodies by minimizing frictions and wear between interacting surface. Hydrodynamic lubricant, a system of lubrication which in which the supporting fluid film is created by the shape and relative motion of the sliding surfaces. That's all from me. Thank you.
Good day everyone. My name is Vishnu Jaisilan. My metric number is B092010016 and I am from class 2 BMMM1/1. For today I want to explain about the methodology of this experiment. For experiment 1, first step we need to use is switch on the machine. After switch on, we need to add lubricant to the cup. Then we need to determine the friction pairing and insert the pin into the holder. After that, we need to lower the loading arm until the pin comes in contact with the disc. Then, we need to add the load weight of 10 Newton to the weight hanger and suspend from the loading arm. Then, we need to adjust the speed to 10 rpm, 40 rpm, 80 rpm, 120, 160 and 200 rpm while taking the reading of measured friction. Next, we need to change the lubricant and weight load of 20 kN. Then we need to adjust the speed and take the reading of measured friction for each speed of 10 rpm, 40 rpm, 80 rpm, 120 rpm, 160 and 200 rpm. Now for experiment 2. For experiment 2, we need to do first switch on the machine, then add lubricant to the cup. Then we need to determine the friction pairing and insert pin into the holder and lower the loading arm until the pin comes in contact with the disc, just as before as experiment 1. But for experiment 2, the next step is we need to add load weight of 10 Newton to the weight hanger and suspend from the loading arm. Then at constant speed of 40 and 160 rpm, we need to add up the load of 15 Newton, 20 Newton, 25 Newton, 30 Newton and 40 Newton. Then we need to take the measured friction for each load. That's all from me. Thank you.
Hi, my name is Chye Wong Jie, matrix number B092010016 from 2BMMS1-1. In this video, I would like to talk about the result and discussion for this experiment. For the discussion question, I will explain each experiment's results, and based on the experiment results, what is the relationship between friction, load, and speed. For graph 1, this experiment was performed at 6 different speed settings under a 10 Newton load to observe the friction of the pins on the disc. From the resulting plot of this experiment, we can observe that the friction force decreases as the speed of the potentiometer increases. Aluminum pins had the largest drop in friction, followed by the brass, which dropped more slowly, while metal wires were more stable. Since they carry the same load, we can say that the coefficient of friction at 200 rpm, brass is the smallest, followed by aluminum and metal. For the second graph, this experiment was performed at 6 different speed settings under a 20 Newton load to observe the friction of the pins on the disc. From the resulting plot of this experiment, we can observe that the friction force decreases as the speed of the potentiometer increases. Aluminum pins had the largest drop in friction, followed by brass, which dropped more slowly, while metal wires were more stable. Since they carry the same load, we can say that the coefficient of friction at 200 rpm, brass is the smallest, followed by aluminum and metal. Lastly, for graph 3 and 4, this experiment was performed at 2 different speed settings at 15, 20, 25, 30, and 40 Newton loads to observe the friction of the pins on the disc. From these two graphs, we can observe that the friction force increases almost linearly with increasing load. The two different speeds also show the same behavior in the other experiments. For example, increasing the speed decreases the friction value. Thank you.
Assalamualaikum and hi. My name is Muhammad Bin Suhaimi. My cut metric B092010016. So today I would like to present about conclusion from our project, which is the conclusion. So we can conclude the higher load of the object move, the greater the friction, and the higher the speed of the object move, so the lower friction up to the limit. So we can conclude, which is this experiment using column law of friction. Okay. Furthermore, which is this project, also we get to know form a film on a metal surface, and then it can converting solid friction into liquid friction for reduce the friction. And then reducing friction prevent heating and wear on friction surface. Okay. Otherwise, which is lubricate oil must be replaced with a new after use, because it has become contaminated and degrade during use. So lastly, if not replaced, its anti friction performance will be reduced. So that's all from me. Thank you.